these methodologies, actually. And if you have any questions, please do not hesitate to ask, because I want you understand the methodologies, the ideas behind this. So if you don't ask, it doesn't matter if you joined or not. So just use your opportunity to ask these questions. I'm starting with TDD. Actually, it is very easy to follow. It is a methodology for developers. It's only for developers, because I'm saying this because the other methodologies are not just for developers. In this methodology, you are writing the tests first before your business code, before you're coding your business logic. So we can call this test first development. And by following these methodology, we have automated tests. So we can automate our tests. And after each refactor, we can run our all tests that we have defined before and make sure that we didn't break anything, break any code, break any logic in our business code. It has very simple cycle, which has colors. Each cycle has different colors, red, green, and blue. The red means a failing test. We start with a failing test. After that, we just write the minimum code to make the test pass. This is our first development. After making it pass, after making it green, we refactor our code and write our own logic, write the logic that we want to code, we want to implement, and run the test again to see we are still a successful test or a failing test. And this cycle goes on because, you know, in development, requirements can be changed, or we might, following an iterative approach, we might have something new to be implemented. So we are following this cycle all the time. So in TDD, we are not thinking about the design. We are just starting with tests. So in our mind, at first we are only thinking about what to test. This is the most important thing about TDD. And in all tests, each test, we are testing one single piece of logic. That's the point of TDD, actually. If you follow this, you will have a software that you develop, which is applying solid principles. This is what all we are trying to achieve, actually. And in our test methods that we are going to see in later slides, we do not do anything. We do not write any business logic. We are not going to compute anything, but just we are expecting outcome by giving an input. So we are giving input and expecting some output from that by using test-driven development. So as this is a webinar, I am not going to write any code, actually. I just have some screenshots that shows what it is, because I don't want to tell only theoretical things. I just want to show you some sample codes to make sure that you understand the idea behind the test-driven development. For example, I have a class. I want a class that validates something. It doesn't matter what to validate, actually, in this example. My example is about ISBN, International Book Number. Actually, it has a logic that validates it. Actually, it is defined. You can find it on Wikipedia, how to validate a ISBN. The logic is shared there. So I want to develop a software that validates ISBN numbers. So I am starting with a failing test. In this example, you will see some annotations and methods. Actually, I am using JUnit here. I'm a Java developer, so I like to use JUnit. So in my examples, we are going to see JUnit examples and Mockito examples, that frameworks I use daily. So in this example, first, I'm trying to write a test that validates an ISBN. So I am writing a failing test first and run it by using a plugin that is installed in my ID, IntelliJ. When I run it, I see that, you can see on the right side, I see that it fails. And the next step is writing, calling my business code, which is not implemented yet. Actually, you can see that ISBN validator class, for now, actually it is not implemented yet. I'm just writing as it is already implemented. After this, I'm starting to write my business classes. So I created ISBN validator class and created a method that validates given string. But in this example, as you remember, the second step is making the test pass, making it green by coding the minimum code, writing the minimum code. So here I'm just returning true to see if the test pass, then it returns true. And when I run my test, I see that I have a green icon on my ID. So I see that it passes. Now I'm sure that when it returns true, when my method, business method returns true, I have a passing test. After that, we are on the third step of the cycle, refactoring. Now I can write, not at first in 2 steps. I check my test actually. I check if my test works well according to the response of the business class, business method. So now I know that when it returns true, I have a test that passed. Actually, maybe I better tell you that I'm using assert true method here, which JUnit provides us. It's just a method that checks if result is true or not. If it is true, the test pass. If it is not true, you have a failing test. That's all. Nothing complex actually. After that, I start to write my business code here. I have a logic. I'm implementing that logic here and run my tests again to see if pass. And after that, you will see that if you write the logic right, you return true and you have a passing test. So the point is to know what to test. What test should I write? That's the main question. If you know what to test, what test that you should write, you can apply this methodology in how it is supposed to be. So first, I'm writing the logic. What should the logic be? That's the question. After I implement this logic, I try to think opposite way. I try to write another test that has the opposite logic. In this example, I'm writing a test method that returns true, that passes when I give invalid ISBN to ISBN validator. It is supposed to return false, right? Then I am going to write a new test that checks if it returns false when I pass invalid ISBN to the ISBN validator's validate methods. So we are trying to enlarge our test cases, test methods to cover all the cases. Actually, there can be some edge cases here. So, for example, it changed to domain, and it changed to the code, the business that you are implementing. You are trying to find edge cases, and you write a test for each edge cases, and probably you will have some error conditions. You might have some checks to be done in your code. Then you write other tests to check if your application, your software throws the expected exception when you give a input for it, when you give a specific input for it. So we are trying to create as many cases as we can. That's the point of the TDD. We are trying to cover all our codes. Actually, there are some tools that checks your coverage, test coverage. You can use them to make sure that you are almost 100%. So it means that you have almost all your tests that you can write. So to summarize rules of testing, we can say that we should test only one item of functionality. By doing this, we will have some more focused class that are those that are loosely coupled, have single responsibility. All these reminds us the solid principles, actually. So we are writing a software that applies the solid principles. So you don't have to write test methods for each methods of your class, business class. It is not expected. It is not true. Just try to understand the logic behind it. Try to find out the cases, and after that, write the test that covers all your cases. And another important thing is that your input and expected outputs must be repeatable and consistent. When you have to make sure that you should make sure that when you run that test, the expected results is always the same. For example, using today is not a good idea in your tests because today changes every day. So try to use something doesn't change. Something is consistent. Something is repeatable. That's the point. Otherwise, you will have some failing tests, and one test might pass one day and fail one day, even if you didn't make any code change. Also, it is not consistent, and it's not TDD here. It's not a good unit test. So benefits of TDD. Actually, I already told this to you, but to summarize, you are writing smaller and more focused classes. So this means single responsibility and loser coupling. We are not coupling this. We are separate them and integrate them together. And we are using cleaner interfaces to easily integrate them. We are using interfaces to easily change the things without changing the other codes. And we have our tests which have our back when we refactor our code. So if you have tests, you feel more confident while you are changing your code, because you know that when you run all your tests will warn you if you break anything or not. And other benefit of TDD is improved developer focus, because you are writing a test and you are trying to make it pass and you are refactoring it. You are always focusing on same logic, one specific logic. After you finish that, you go with another test. So this improves developer focus. You are just focusing on one thing in a time. And actually, you have a documentation. If I'm a new member in a team, I can go to test and understand what they have and how their code behaves, how their methods return for specific inputs. And actually, this is related to the first topic: smaller, more focused classes, loser coupling, better code quality. We will have better code quality when we apply TDD in our code. And for sure, we will have reduced bugs here. Another advantage of TDD is using CI platforms, continuous integration platforms, that runs our all tests, full tests, before any build. So we make sure that we are sending a code to the environment that has no defects. If our test methods covers all the cases, actually, this works. As an example, testing framework for Java, I'm using JUnit. Actually, I don't want to deep dive into this topic here. Just I wanted to mention that I'm using this, and the examples that I have shown to you are written by using JUnit here. It provides you some annotations, assertions to write your tests easily, but actually JUnit is not enough. We are going to talk about another topic that we need. In test-driven development, our tests should focus on a logic, a simple and single logic. So we are not caring about the third-party systems or web services that we are consuming, so we want to get rid of these dependencies during tests. So we need to run our tests without external system dependencies. Because if the third-party systems doesn't work, is not online, we will not be able to run our tests because we are dependent to them. And actually, third-party systems data might change. So this makes our tests not consistent. So we don't want these third-party applications, web services, DBs. We only want change. We only want to test our own code. This is the point where we need to have mocking. And as mocking framework, I'm using Mockito. It provides us dummy implementation of an object, and we can configure this object to perform a certain behavior during test. We can configure it, and we can say that when I call this method of this object, when I pass this variable, pass this value, please return me this. We are configuring its behavior. So we don't have any dependency for third-party applications, web services, databases. So this is why we need Mockito, because we don't want any dependency during our tests. I wrote this, I created this slide to make it more sorry, to provide you a code that visualize how mocking. Actually, it is very simple. You select the object that you want to mock, and you can use annotation and method. There are many ways. In this example, I'm using method. Actually, in normal life, in daily life, I'm using annotations. But we are mocking the object by using mock method here, and we configure its behavior. And here it says that when lookup method of database service is called with an ISBN, it returns a book, new book, with the given values. That's it. It's so simple. So by doing this, I don't have any dependency, and I am just testing my own code, not the third-party system. And this is actually not info. This is not a. This is extra info. I just want to mention that JUnit 4 and 5 has a big difference. What is the difference? JUnit 5 has an API, test engine API, which provides us an API for writing new testing frameworks. This is the main difference. In job interviews, you will be asked questions like this. So I just wanted to mention this because actually, if you are searching for a job, TDD is a must for a developer in these days. If you do not know anything about TDD, you will not succeed during your interview. This topic is the most important topic in these three topics that we are going to talk about today. I think, yeah, this is the end of the TDD. Please ask questions. If you have any questions, please do not hesitate to ask. Any questions?
There was one, and it was from Alper Kopuz. Do you believe that failing test is necessary for TDD? we should have
Yes,
test failing possibilities rather than testing success stories.
actually, there is a case that I already know. Sometimes you might have many tests and you are creating a new one and you forget to write the test annotation there. If you do not check the failing test, you are not sure that your test is working. Because first we are just testing our tests. We are writing the failing test to see if it fails. Because if you don't see that it fails, maybe you didn't write the test annotation over your method, and that test isn't a test actually. So to be sure that you are writing the test method in an appropriate way, you better test the failing test. Actually, it is very fast thing. It is very quick thing. You know, you are just writing fail. That's all. I don't know if I understood the question. Maybe Alper can explain me if there is something additional to it. But as I understood, he just want to start with the green test, right?
Yeah, I think so.
I think so, but I think he left, so
Oh, really?
I don't know. I think you got the question right, and we got it answered at least.
Oh, okay then. Okay. Any other questions? Please join, guys. I feel like I'm talking with myself.
By the way, you can write your questions via chat, and we can read we can ask your question
Yes,
as well.
yes. Don't be shy.
Yeah, because as the Javit mentioned, TDD is most important on the market. It is yeah, we are writing TDD every day. All of the companies or recruiters, they are asking how you are good on TDD and what is the step of TDD, what is red, green, blue, mocking, what is mocking, which kind of framework are you using? Yeah, as the one another important thing that Javed is mentioned. Yeah, when we start with test, we are able to write testable codes. For the opposite side, especially for the complex projects, when we start directly on the implementation side, really it is nightmare to write a test for that kind of big project. And if we didn't follow the solid principles as well, yeah, the code complexity will be more, and then we will spend maybe more time for testing after the project. Yeah.
As far as I see, developers doesn't like this methodology at first. They think that this is just an extra work for nothing, you know, because when you got used to it, you start to get the advantages, get from it. And it's much better, as you said, Rasim, writing tests for a code that is already implemented. It's like a nightmare. Sometimes you cannot write because it's not well structured. So, and I can say that being a good developer is all about if you have a good habits. This is a good habit. If you follow TDD, it is guaranteed that you have better code quality. Any question? If you have, please ask, because this is the most important topic, I think.
I agree with you. I mean, TDD is, at the beginning, it's a little bit different than the usual programming concept, because in usual programming, what you do is you are just getting your problem domain, and you are beginning to code with it. So we are directly begin by coding, and then later on you are testing it. But if you do the test first approach, it allows you to discover the problems before doing actual coding. So it will be much more easier for stakeholders as well. I mean, for people who look at your codes, how it is implemented, it's much more easier to understand, because if some part of your code is passing the test, then actually it is implemented as required. So that is, I think, the most important point in TDD, test-driven development. So if a code passed its tests, then everything must be working as planned. So adapting to it is important. It takes maybe more time, but your code is much more secure and much more concentrated on the problem that it tries to solve.
Actually, you might lose more time if you don't write tests first. After you're implementing your code and you try to write tests, you might lose more time because maybe you write your code in a bad way, so that cannot be tested.
Especially in a big project, you cannot turn back. That's the main problem, because you cannot change that functionality if you implement it, or if you analyze the problem wrong.
Yeah, that's true. Okay, it seems that there is no other questions.
Yeah.
I expected more, but any in the chat? No. Okay.
Sure, there is not.
Then I'm carrying on with BDD. If there is no questions, okay. BDD is not only for developers, it is for whole team. This is the main difference between TDD. Actually, it is also an iterative approach. It evolved from TDD, and it is an agile. It aligns itself in agile framework. It's an agile methodology. If you are using agile methodology, you can easily use BDD. The main focus of this methodology is the behaviors. The first TDD's focus was the tests, the code. But here, we are focusing on behaviors with whole team, not only for developers. By using DDD, we are communicating well between technical and non-technical people. We have a common language we are working on that everybody can understand. So this is actually agile. I think who are already using agile methodologies, applying agile methodologies understood me. The main difference in BDD, we document scenarios, user stories, acceptance criteria, and our documents are executables. We can run our documents to test the behaviors. This is the main difference between regular agile, normal agile, and agile with BDD. Oops. Okay. With all team members, we are creating real-world examples. Just first, we are trying to understand the problems. We are creating real-world examples, and we discuss those examples with the team. Then we are writing scenarios and acceptance criteria in a shared language that everybody can understand, and also automation tools can execute. This is where BDD shines. I told this is an agile methodology. You can apply it if you already have agile process. In BDD, meetings are so important, and different point of views are also important. We call the group three amigos: business owner, tester, and developer comes together and discuss about the problem, try to find out the scenario, and try to find out the acceptance criteria by looking at the problem by their point of view. So, as you already experienced, every role looks to the problems in a different way. Everybody asks different questions. Tester asks different kind of questions. Developer asks different kind of questions. This is the importance of three amigos. We have three people have different point of views. We have three phase in behavioral-driven development. Actually, maybe I can show this to you. This is much better. Discovery, formulation, and automation part. We have three parts, three phases. In the discovery, we are just discussing about the problem and try to understand it. In formulation phase, we are just documenting our scenarios, which are written in a language that can be execute by automation frameworks. In the third phase. So in the third phase, we start to write our code by using our documents that we wrote, that we created in formulation phase. So in BDD, we have some things that we need to know. Role feature reason matrix, given when then formulas. We are using a language that everybody can understand, but it has to be structured language because automation frameworks are going to execute these documents. As you see, this is already iterative methodology. And what is role feature matrix, reason matrix? It is just a user's story. It is just a scenario. I want so that. Let's go and see an example to make it more clear. In this example story, it says that as a driver, I want the vehicle to determine the speed limit and set the speed to that limit so that I do not have to pay attention to speed limit. I think it is called cruise control in cars. You give a speed limit and the car maintains its speed. You don't have to do anything. So the acceptance criteria is in this scenario, car maintains speed close to speed limit, but not above it. Okay, it is clear, but in BDD, we are trying to give concrete examples. So we are trying to give concrete examples to make sure that developer understand the need here. Before going that phase, I want to explain something more. Given when then format. This is a format that automation frameworks can understand, can execute. In our scenario, we are writing our scenario in this format. Given a speed limit, when the car drives, then it is close to the speed limit but not above. But this is not enough, so we are giving values to make it more clear. Given speed limit is 50 miles per hour, the car drives. When the car drives, then the speed is between 49 and 50 miles per hour. This is more clear. It's clear. And we are starting to enlarge our scenarios by talking with three amigos. We are adding new cases, edge cases, new examples, new acceptance criteria. In this case, in this our example, we are adding another acceptance criteria, another scenario. Given speed limit is 50 miles per hour, when speed limit changes to 30 miles per hour, then deceleration rate should be less than 5 feet second. So it shows that the deceleration rate should be given a constant value. This is another case. In DDD, we are growing our cases, accepting criteria horizontally, and we are adding new examples for the stories, for the features vertically. So we are creating some executable documentation. This is the point of BDD. And this given when then keywords are part of a language which is called Gherkin. Now in this example, I am talking about Java, and I'm talking about Cucumber framework. Actually, there are other frameworks for BDD. There are other automation frameworks for Java, but I am using Cucumber, so my example is based on Cucumber here. Gherkin is the language for Cucumber, and the advantage is it is almost like daily spoken language, daily spoken English. It is business readable language. So, and I see some topics on internet BDD versus TDD. This is not right. BDD and TDD can work together. Actually, it's a good idea to use TDD and BDD. BDD focuses on behaviors, and it is for all team members, full team members. So you can find out the stories, scenarios, acceptance criteria by using BDD and document them. And that can be executed by automation frameworks. After that, when you reach the development phase, you can use TDD that we already seen in the previous slides. You can use that technique for your development. The advantage is BDD makes sure that developer understood the business needs, the business owner's needs. Because if you do not follow BDD, developer can understand something different than the business people's need, and he or she can write his tests, and all tests can pass. But the developer doesn't know that she is doing the wrong thing, implementing wrong thing. BDD helps us to make sure that we understood the need of the customer, need of the business person. So this table tries to explain the thing that I tried to explain. In test-driven development, we have lots of tests may or may not meet the business value. Actually, we don't know. We are writing tests according to what we understood from the product owner of business analyst. But we are not sure if the test meets the business value or not. But if we combine this methodology together, we are more secure. We are following a more secure methodology, and everybody in team understands the needs of the customer, needs of the business. So we don't lose time because in waterfall methodology, you are taking risk even if you are writing test-driven development, if you are following the test-driven development. But in agile frameworks, if you combine the agile frameworks, BDD and TDD, you are more you are more secure. So I wanted to show you an example to make it clear. This example is based on Cucumber. So I'm using Maven, and I'm adding Maven dependency to my project. It doesn't matter. You can find these dependencies on internet. Then the documents that test behavior are called feature documents in Cucumber. I'm creating my feature document. In this example, I know it's always stupid examples when we try to make it easy, more understandable and we select stupid examples. Don't think about that. Just try to understand the idea. Think about that. We are trying to write behaviors for a software that checks, is it Friday today? Okay, this is my feature file. As you see, the orange words are keywords for Cucumber. We are defining the feature name first. Then we are explaining our scenario by using given when then formula. In this example, our feature is it Friday yet? We want to check if it is Friday or not. Our scenario is Sunday isn't Friday. Given today is Sunday, when I ask whether it is Friday yet, then I should be told no. This is the business need. Our business owner comes up with this scenario and tells us that check this. And we write this document. Then we run this document by using a plugin. Which is integrated in your integrated development environment. I'm using IntelliJ here, and I installed a Cucumber plugin. So when I run that, I got some errors because I didn't do anything. I just wrote my feature file. That's it, nothing else. So it tells me that you have one scenario which is undefined and three three steps that is given when then steps. We call them steps. We call each steps. Three undefined steps. The beauty of Cucumber is it gives us an example code for starting. To start. As you see on the screen, we have three methods for each step that are provided by Cucumber. So I copy these methods and create a class to make them runnable. To make it runnable, I'm configuring my IDE. I'm creating a new package, new folder, and put my all feature sets there, feature files in that package. And as a configuration, I am gluing this package to my Cucumber plugin. I say Cucumber that please check step devs package for my feature files. After that, I write a class that has three steps and their methods. Actually, I didn't write any code. I just copied the methods from my terminal and paste it to a new class. So it is so easy to start writing Cucumber code. And here we have three steps, and by default, they are throwing pending exception. After I write my copy and paste this code, I run my test, and I got another result, which is different than the before. Now it says that one scenario that is pending, three steps, to skip one pending because Cucumber tried to run the first step, and when it shows that it realized that it is still pending, it doesn't run the other steps. So we are getting close to the green part. Now, I'm starting to implement my feature steps in the code here. In given step, I am setting Sunday, setting today to Sunday. In one step method, I am calling a Friday checker. This is a new class. I implemented. I write an implementation which is dummy here, as you see on the left side of the screen. I have a Friday checker class which returns null, which has a Friday method which accepts a parameter, string parameter, which is the day. And in then method, then step, I am checking the result as I do in test-driven development. I'm using an assert equals method and check if it is the expected result. So as you see the annotations, there are some variables, there are some text there, which shows us that the code is going to bind values to it. So here, today is Sunday, and after you run this run this feature, Sunday will set automatically if you parameterize it. I'm going to show you that because you don't have to write many given methods for all days or each day, because as you can imagine, we are going to check the opposite way also. It is like the TDD approach. We are testing a behavior and we are testing the opposite of the behavior. We are supposed to do that. After this dummy implementation, when I run my behavior tests, I get another error. Now I have a failing behavior because I was expecting nope as answer because Sunday is not Friday, but my software returns null. So I have a failing behavior here. After that, as in TDD, I'm writing minimum code to make the behavior pass. So I return nope for any input, for every input. And I run my behavior and I have one scenario that passed and three steps that those passed. After that, I'm writing the opposite scenario in my feature file. So in this scenario, it is Friday And when I check, when I call my software, when I trigger my software, I'm expecting, thanks God, it's Friday result. So I edit this to my feature file and I run it, and I have an error, as you see. One unidentified, one undefined scenario. And so it offers me a code, sample code again, and I copy and paste it. The new step, the given step, today is Friday, and I set today to Friday. Now, when I run this feature file, I got error because, as you remember, the method was always returning nope. Now I have two scenarios, one and they are opposite to each other. So now it's time to write my actual code, refactor my code, and make it make it a code that suits business needs. And in my business class, I change it and I check really it is Friday or not, and return a result according to given day. When I run this, when I run my behavior documents, feature documents after this change, as you see, my two scenarios are passed. I know it is exhausting to writing each scenario one by one explicitly. Actually, there is a parameterizing way. You can write this way your scenarios and give inputs and outputs, and Cucumber will check all inputs and outputs for you. In this example, as maybe you noticed that we are using scenario outline keyword here to mention that this is a scenario which can be parameterized. And we have a day and answer parameters here, and in below we have example sets, which has day and answer for each. Now I change my given step here, as you see, sorry, as you see, and I made it a parameterized step by changing the parameter which is given to annotation. Actually, you don't have to write anything. If you run this, you will get an exception and you will have a code that is offered by Cucumber, and you can copy and paste it. You do not have to know the syntax of the annotation. It offers you. After that, I changed my feature file, which can be parameterized, and I gave the parameters, and I ran it. As you see, each scenario is being run and checked by Cucumber. We have 3 scenarios, and all of the 3 already passed. Okay, this is end of the BDD. If you have any questions, please do not hesitate to ask.
Any question, guys? Yeah.
So is it always implement BDD, or is it depends on project? I mean, is it a methodology that we always need to implement in our business, or is there any cases that we need to choose implementing our project with BDD approach or not using it?
Actually, if you have a very simple project that has very simple needs that you provide to your business customers, you don't have to. But if there is many cases that you have to cover, it's a good idea because you don't take risks that someone might understand the business need wrong and you can lose time. You know, all we are developers and know that sometimes there are some misunderstanding and we lose time. So to prevent this, we can use BDD. Actually, it is not extra work. If you are applying Agile framework, you are just change your documentation, way of documentation. You are not doing anything else because as you see, integrating the feature document to your code, it's so easy. It offers you the code that you can apply, that you can add to your project. It doesn't take too much time, but it saves you it saves you in misunderstanding the misunderstanding situation. But if you are writing some project that is not complex, that has some scenarios, so little scenarios, so few scenarios, you don't have to do that. But actually, it is not too much work. TDD is too much work if you compare to this, but TDD is must for me. And BDD can be used to make sure that you understand the business needs and to develop your code in a more secure way.
So another question then, how can we integrate Cucumber with TDD? I mean, is there a way to integrate them together, or do we need to first do BDD and then be sure that we understand that the business needs, and then write our tests as another project or another step?
Actually, you create your documents in BDD and start to develop. You integrate your feature documents by using Cucumber annotations. Then you are free to use TDD. At that point, you are nothing to do with BDD. You have just documents that can be executed and check if the behaviors are working, behaviors are what they're supposed to be. And after that, you can apply. I know in this example, it's not easy to visualize. It's not easy to understand the TDD and BDD. Maybe if I had an example combination of BDD and TDD, it might be much better. But at the same time, it might have been more confusing. So I decided to just only show you the BDD. But after you apply your feature documents integrated to your project, you are free to write BDD. For example, here we wrote a Friday checker. We returned Friday or null, then we check the behaviors. After that, you can write TDD. You can write TDD to write your code. It is up to you. It is up to you. There is no actually relationship between these. These are two things, two plugins you can plug in your project. They are not dependent to each other.
We can easily integrate them together as well. I mean, we can use maybe the same code base for both TDD and BDD as well.
Yes, you can do. Because one defines and checks the behaviors, the other checks the functionality. So in behavior, if you are testing one behavior, there might be many functions under that. It covers many testers. One behavior test covers many unit tests. Might cover many unit tests. But one is behavior, one is function. So they have different point of view. So you can write, you can use the same code base, and you can apply two methodologies at the same time.
Thank you very much.
Thank you.
Any more questions, guys? I think we have a question. You have it. It is
Okay.
on chat.
Mm-hmm.
It's from Ali. I may have missed that part, but does Cucumber specific to Java? If so, do you have any suggestions for JavaScript as well?
I'm sorry, I don't know other languages. I'm always writing. I've been writing Java, coding in Java for 15 years almost, and I don't know anything. Actually, I'm a backend developer, and I don't have a good relationship with JavaScript. I cannot say, but I only know JBehave and Cucumber for Java. But I know that there are many frameworks for each language, for many languages. Actually, you can find it by searching on Google. It's easy. Actually, there are many. Maybe if anybody knows, please share the information with us. I don't know.
There is a Cucumber JS project, I think, which might work, but I'm not sure if the original Cucumber supports JavaScript as well.
Mm-hmm. Yeah, me too. I don't know.
Any more questions? Okay, I think we don't have any more questions, right?
Okay, then I'm carrying on with DDD. Actually, DDD is very big topic, really big topic. We cannot explain it in a good way in a short time. So I just want to give you some minor information about it. The idea's father, the DDD's father, is Eric Evans. He wrote a book in 2003 with a name Domain-Driven Design and Tackling Complexity in the Heart of Software. Actually, this explains us something. This methodology. Actually, this is not methodology. This is approach, and there is no framework related to this. This is an approach, and this can be only applied to specific domains which have complexity. As we developers, we are always trying to make entities, everything very flexible. But in this methodology, you can rewrite code. You don't have to reuse code all the time. You are just trying to split the subdomains of a specific domain and coding each other independently. And you are writing loosely coupled domains here. And other book that gives us some examples, implementation examples about this domain-driven design by Von Vernon. If you want to learn something about domain-driven design, you can read these books because these are holy books of DDD because the idea comes from these books. So I wanted to share this. So what is DDD? DDD is an approach for complex needs, complex domains. Our focus is only domain here. We are not focusing on architecture or design. We are just trying to understand the domain, entities under it, values under it, events under it by using ubiquitous language which can be understood by everybody. First, you create your own vocabulary and you make sure that everybody understands the same thing when they hear a word, when they hear something related to the domain. And this meaning can change context. A product means something else for shipping domain and something else for sales domain. They have different properties. So we are trying to define these differences for each domains and document it here. DDD gives us structures and terminology to follow to solve the complicated problems of domains, complicated domains. What is the goal of the DDD? Putting the primary focus on the core domain business needs. Not caring about the code design, we are just implementing the real world models in development side, in software side. And we are making a software for a specific need. It's not for anybody else. We are just creating our software for a specific company's needs. That is why called complex. In DDD, we are splitting the system into many contexts and try to find the entities in that. And try to understand what customer means for sales department, sales context, what customer means for support context. In traditional way, we are just trying to create one customer and use it in whole program, whole software. But in this approach, we are creating different objects can communicate each other. And they are splitted domains. They are not dependent to each other. So code reusing is not the issue here. We are not focusing on code reuse. We have different contexts, different objects, which can be integrated, which can be communicate each other by using messaging systems. For example, a domain can communicate with other domain by throwing a domain event, which is handled by messaging mechanisms. For example, Kafka. They are throwing events, they are sending events to messaging mechanisms, and consumers, the other contexts, the other subdomains listen this messaging mechanism and gets the data from that. We are separating the things. So this is, you can think like microservices. There are some good examples related to DDD, which is implemented by using microservices. And domain-driven design. Actually, I forgot to mention it. This is a design approach. The first two was about development, but this is a design approach. So if you use this approach, you are designing your software by using this approach structures and terminology. So it has some rules. Actually, it has many rules. That is why I don't want to deep dive into this topic, because we cannot finish it today. It provides us some terminology. Sorry. If we apply that, you can solve the big problem, complex problem. It has some building blocks, entities, value objects, and it has an aggregate term. Which means that which has many entities and values, and aggregate root can communicate with other aggregate roots. In entities and value objects are abstracted from the outside world, and we have services, repositories, factories. If you use this terminology and structures, you can solve the complex problems easily, because in other systems, we are trying to make generic solutions, and we are focusing on the architectures behind the code. We are trying to make them more flexible. But in this approach, we are just trying to understand the domain and reflect it to the software code side. That's it. But it is very complex complex topic, so I don't want to carry on more. I don't want to tell anything more. This is the end of my presentation. Yeah.
Thank you, Javed. By the way, yeah, you don't have time to talk about more about the DDD. Yeah, yeah. But you know, so far you talked about very important three topics, especially for the BDD side. It was very useful for my side, to be honest, because yeah, TDD in our life we are using, every company is using, but BDD, you know, some specific companies they are using. It is not popular as much as TDD, but what I understood, it is not so complex. It is very useful, and our test becoming very meaningful for everybody, not only for developers. For that part, maybe in my next project, I will try to use BDD. Thanks for that. And DDD part, as you mentioned, I want to go deep about DDD. Maybe we can create some workshop about it with you. Thanks for all. And if you have any question, you can ask.
I also want to add something about it. DDD, especially in UK, most of the government projects depends on DDD. So most of the government projects, they need you to know about DDD domain. So at least for public sector in UK, DDD is nearly a must.
Yeah, if the domain is complex, for example, I'm working for a bank now. Banking is a complex domain, and we are using DDD. Actually, we are trying to use that. It is not easy to use because the other people, the other guys in the team doesn't know that. We are just getting used to it, but it is the best way to solve the complex problems, solve complex domains. So government is one of them, yeah, actually.
Any questions?
By the way, we will have some workshops, especially about TDD. As I said, it's a must for developers. If you are looking for a job, it is the first thing that you should know to succeed. So if you are interested in this topic, please follow us, and we will have some workshops soon.
Yeah, we are planning our workshop 20th of this month. Yeah, they can follow us. To be honest, I am managing also recruitment process. I am doing pair programming with the guys, with the candidates. Yeah, we are starting with TDD. I think the TDD is really important. Yeah, BDD and DDD and other technologies. Yeah, you can you can learn in a theoretical way, but TDD must. And I think your workshop will be very useful for their career, and they will be very comfortable in their interview as well. Yeah, please follow our events and workshop, and you can join. Yeah, it is very useful for their career. Yeah, if you have any other question, please ask. Otherwise, we will go.
There is a question, I think.
Yeah.
Ah, okay. That's for me. I will be sharing them. I will be sharing them.
Okay.
Otherwise, go.
Yeah. Alper already recorded the events, and we will publish on YouTube channel. And when we publish, and then we will send a message via Meetup event, and you will get notification about it. You know, the link and other details, or contact details as well. No worry, don't worry about it. Yeah, if you don't have any other questions, I think we can slowly finish our events.
Thank you very much, Cavit, for today's information. And well, if anyone interested, TDD will be, I believe, TDD workshop will be very useful for everyone who wants to get ready for a job interview, or who wants to reskill themselves. So I believe it will be a very useful workshop too.
Yeah. Yeah, I think there is no other questions. Thank you, guys, and follow us. We will continue to do such events about our careers. You know, to be honest, I am doing that kind of events just first of all for my career, and then your career. because I am learning so many things from these guys. Thank you, Cavit. You shared all of your experience, especially that kind of that kind of commercial experience. Yeah, we work together. You have really strong finance experience in a bank. You know, I think more than 10 years you have finance experience. Yeah, your experience was very important for us, because they were the real experience from the real life. Yeah. Thank you. See you guys. Yeah.
Thank you, everyone.
Good evening.
Good afternoon.
Yeah, thank you. Bye bye.
Bye bye.